Chapter 3, we are going to be talking about elements and compounds. If you remember from Chapter 1, when we were talking about matter and we had pure substance, under pure substance we had elements and compounds. So now we're going to delve a little bit more into elements and compounds. First thing is, what is an element? Element is a fundamental substance that can't be broken down into anything simpler. It's like the most simple form in chemical means. So it's a building block of everything, and elements can be natural or made in lab. We're mostly going to be focusing on what's natural usually. When you make stuff in lab, there's all kinds of stuff that can happen. Some of them aren't even on the periodic table or haven't been added yet. So anyway, the smallest unit of an element is an atom. So one atom of the same kind, a bunch of it together makes one element, okay? So and then how much of it, then we'll be talking about amounts later, but element is made of atoms. And then right now we have 118 elements known. 88 of these are naturally occurring. And sometimes you'll see research of people finding new elements. A lot of them aren't very stable, but it's kind of cool that it's still happening. At room temperature right now, bromine, Br2, and mercury, Hg, are liquids. You don't need to memorize all of this, but it's pretty cool that 2 of them are liquid, everything else is solid, and then some of them are gases. So at room temperature, hydrogen gas, H2, we have nitrogen gas, N2, oxygen gas, O2, fluorine gas, F2, chlorine gas, Cl2, helium gas, He, we know helium balloons, neon gas, Ne, argon gas, Ar, krypton gas, Kr, xenon gas, Xe, and radon gas, Rn. If we take a look at the human body, what are we mostly comprised of? Most of the stuff we're made of is oxygen, carbon, and hydrogen. And obviously we have small amounts of other stuff and some metals too, but like chromium and copper, but they're really, really small amounts. And we also have a little bit of potassium too. So each element, we have a symbol for it, and you're going to have to start memorizing as we go along. So memorize the common ones first. Iodine is I, barium is Ba, and then this guy here, N, is going to be for nitrogen, and then Au here is number 79. It's actually gold, but gold's old name is aurum. So that's why it's Au, because it really was aurum, but we used the name gold here. So let's take their old names here in a second. So we have some other names here. These aren't the old ones. Some of them are mixed. So aluminum is Al, antimony is Sb. So that obviously has an old name, but this is antimony here. And then we have argon, Ar, arsenic, As, barium is Ba, bismuth and pepto-bismol is Bi, boron is B, bromine is Br, cadmium is Cd. So these are common here. We have calcium as Ca, carbon as C. This one's going to be really, really common, so we'll see it all the time. Chlorine is Cl, chromium is Cr, cobalt, Co, copper is Cu. You'll be thinking, why is copper? So again, this one doesn't really match name, so this one has an old name here. The old name is cuprum. Fluorine is F, gold is Au because it's aurum, helium He, hydrogen H, iodine I. And then we have iron is Fe, another old name because it's ferrum. Lead is Pb, plumbum. Lithium Li, magnesium Mg, manganese Mn. Mercury is Hg, Neon is Ne, nickel is Ni, nitrogen is N, oxygen is O, palladium is Pd. So I'm not asking you to memorize all of these right now, but a lot of the common ones you'll have to start to recognize. So as much as you can, okay? Phosphorus is P, platinum is Pt, plutonium is Pu, potassium is K, radium is Ra, silicon Si, silver is Ag, formerly argentum, sodium is Na. Again, this is so different, but it's because Na is natrium, but we call it sodium here. So just remember, like table salt is sodium chloride. This is Na right here for sodium. Strontium is Sr, sulfur is S, tin is Sn. It's really staining. So titanium is Ti, tungsten is W. This is another super weird one. Used to be called wolfram. Uranium is U, xenon is Xe, zinc is Zn. So some of the names that didn't agree: antimony is stibium Sb, copper cuprum, gold aurum, iron ferrum, lead is plumbum, mercury hydrogyrum, potassium kalium, silver argentum. So these were the names. You see how they follow the old names. So some of these are a little bit different. You probably want to learn these. It helps you because they're like so different from the symbol. Just know that you don't have to learn the old names. It's okay if you don't know the old names. Sodium is Na because of natrium. Tin is Sn, stannum. Tungsten is W, wolfram. See, it says these symbols are in use today even though they do not correspond to the current name of the element because these are the old names. So let's talk about element symbols. The first letter is capitalized, second letter is going to be lowercase. So like cobalt. Cobalt will be C, capital C, O, lowercase. Because if you put capital C and O, it actually would mean carbon and oxygen, which would mean carbon monoxide right there. So it's completely different then. So you have to be careful to write C, little o, not C, capital C, and capital O, because it means something completely different. So let's talk a little bit about our periodic table here. The periodic table was designed by, well, a lot of people put them kind of work together, put together, but Mendeleev is the one that kind of started organizing them based on their properties. Things that are similar in chemical properties are placed in columns called groups. So going down a periodic table, we have groups here, and this is one of the groups here. One of the group's special group name is noble gas. It is the last group in group 8. It's noble gases. And all of them are unreactive. So helium, neon, argon, krypton, xenon, radon, they're super stable. They're not very reactive. And it's good for when you need an environment that unreactive gases are needed. Like, for example, air-sensitive chemistry. Instead of using air, we use argon. All right, so these columns here are representative elements or main group elements. So we talked about noble gases. Their last group, group 8. See group 8A, that's what we're talking about. We're looking at A's, okay? So group 8 is noble gas. Group 7 is called the halogens. And then group 1 is called alkali metal. And then group 2 is alkaline earth metals. So those are the ones you kind of want to know. And then in the middle of this blob here, that's not the main table, main group elements. It's transition metals right in the middle here. The 1A, 2A, 3, 4, 5, 6, 7A, these guys are the main group elements. So we'll be focusing a lot more on the main group and much less on the transition metal. But it does occur, we still need to learn some stuff about it. So here's more that we can show you. We have metals and nonmetals. The nonmetals are on this side, on the right side. The metals are on the left side, and obviously all the transition metals are also metal. And then we have some of those in between metalloids. So the metalloids are the gray. We have this few right here. Those are in between metals and nonmetals. So a little bit about metals. Metals are solid at temperature except for mercury. Mercury is a liquid. Metals are shiny. They're good conductors of heat and electricity and can be shaped or drawn into wires. So most metals are considered having high melting point and high density. Common metals, we have aluminum, gold, platinum, silver, tin, and iron. So metals typically are very happy to combine with non-metals, but they rarely combine with other metals, like to form a reaction with it. So free states, copper, silver, and gold, you can find those metals pretty easily. Copper is like a brownish reddish color. Obviously, we know color gold and silver. And then we can mix them. They can't combine, like react, but we can mix them to make alloys. So like alloys, homogeneous mixture, like solutions, but they're really alloys. So it's a mix of different metals. So we have brass as an example, bronze, steel, and coinage metals. So we use for coins. On the other hand, nonmetals are not shiny. They have low melting points and densities compared to metals and are poor conductors of heat and electricity, which is the opposite of metals. And nonmetals combine with each other, and also they combine with metals. So if nonmetals combine with nonmetal, we make molecular compounds. If they combine nonmetals and metals, we make ionic compounds. And they actually combine in different types of bonds. We'll talk about that some more. Nonmetals that we are commonly aware of: carbon, nitrogen, oxygen, sulfur. Those are pretty common. That's sulfur right there. So in between the metals and nonmetals, we have metalloids. They are called metalloids because they have properties between metals and nonmetals, kind of like in between. So metalloids like boron, silicon, germanium are used in electronic devices, a lot of your semiconductor chips. So what is the symbol for silver? Symbol for silver, silver is called argentum in its own name, so it would be called Ag. So what about this? S right here would be sulfur, Si would be silicon, Au is gold, old name for aurum, and Sr is strontium. Elements are reactive and combine with other elements to form compounds. So most of the time they're combined with other stuff, but rare ones, the noble metals, gold, silver, platinum, because they're so low reactivity, are usually found by itself, uncombined in nature. Air is a homogeneous mixture of diatomic elements. So we were talking about elements, right? So elements is one type of stuff, like on a periodic table. If it's hydrogen, just hydrogen. Oxygen, just oxygen. But we have diatomic, that means like we saw the gases that we listed. N2 for nitrogen, O2 for oxygen. And then we have H2, all the diatomic means there's two of them. So when you write them, you write N2, and this is O2 because it's diatomic. All right, so for next one, a list of diatomic elements that we have. We have H2, we talked about the gas, N2, the gas, O2, the gas, fluorine, also gas. And then chlorine is gas, so obviously these are so pretty common. Hydrogen is really reactive. They used to use hydrogen for hot air balloons, but because it would blow up all the time or catch on fire, they started using helium instead. Helium is more stable because it's a noble gas group. We have nitrogen gas, oxygen gas in the atmosphere. Fluorine gas is pale yellow gas, so hopefully you never have to see it. Chlorine gas is greenish yellow gas. You don't want to see it either because it's dangerous, toxic. We have bromine. Bromine is going to be found in liquid form. Remember, it was one of the liquids. Br2, reddish brown liquid. And iodine is bluish black solid in the normal state. All right, so compounds and formulas. So we were talking about elements with their atoms being the smallest parts, and then compounds are going to be made from different kinds of atoms, different elements combined together. So like maybe carbon and oxygen, hydrogen and oxygen, whatever they're mixed, then it becomes a compound. So for example, water molecules are H2O. It's made of O2 molecule and hydrogen molecules, H2 and O2. And then you put them together as H2O. They always combine in whole number ratio, so we don't use like partial numbers. So like, see, one thing of O2, two things of H2 gives you two things of water. So different ways they're bonded. We talked about how if they're non-metal and non-metal combined together, we get molecular compounds. Metals and non-metal combine to get ionic. So this is metal, that's non-metal. Sodium and chlorine make sodium chloride, that's an ionic bond. Water is hydrogen and oxygen, both of them are non-metal, so they make molecular compounds using basically a type of bond called covalent bond. They share the electron density. And for metal and non-metal is actually ionic. Positive charge versus negative charge or electrostatic attractions combine them together. So this is an ionic bond. This is a covalent bond, and this is called a molecular compound. This is an ionic compound. So key difference is ionic has metal and non-metal. Molecular compounds have only non-metals. So let's put that down. Non-metals only. And this one is metal plus non-metal. And like we mentioned, it talks about the bonds. Covalent bonds for non-metals. Positive and negative charge is ionic bonds. Molecules are made are the smallest parts of a compound. So compounds comprise of molecules, and molecules are made out of two more atoms. So a molecule cannot be further divided. If you divide it further, you're going to change it. It's no longer that molecule. So we have an example. If we write the molecule CO2, carbon dioxide is my compound, and the molecule is CO2 by itself. It's because it's got one atom of carbon and two atoms of oxygen. So that's what this is, one molecule of carbon dioxide. And if you want to, carbon dioxide is called a compound, a bunch of carbon dioxide. Now we can start weighing out carbon dioxide, what the mass of it is. Another example of a molecule is like water, H2O. It's made out of two hydrogen atoms and one oxygen atom. So this is different because like when we were talking about elements, element only has one thing, like diatomic elements that were different. Remember, diatomic elements, we have O2, we have H2, or we just have an element, sodium or copper. Those are elements. So these are elements. And these are diatomic element. This one's regular, it's one atom element. And up here, these are called compounds. Next thing we want to talk about is ions. What are ions? Ions are just charged atoms or groups of atoms, so they're charged, either positive charge or negative charge. Positive charge ion is called cation. Negative charge ion is called anion. So you just want to remember positive is cation, negative is anion. I'm going to start talking a little bit about formulas of compounds. How a chemical formula shows you what the ratios of the symbols of the elements we have and how many of what the ratios are from one atom to another atom. in a compound. So like sulfuric acid is well, it's an acid, but it's a compound, right? Because it has different things in it. So it actually has 2 hydrogen atom, 1 sulfur atom, and 4 oxygen atom. And then so the formula you would write HHSOOOO. That's kind of, it looks silly, right? So we combine it together. We put together H2SO4, where H2 means there's 2 hydrogens. So if you notice, a subscript number means there's 2 of the letter in front. An S here, because there's only 1, we don't have to write the subscript 1, we leave it. And then O4, that means there's 4 oxygens. So we want to start talking about formulas of compound. It has the symbols of all the elements in there. And if we have one of the element, we need to write the subscript. So just keep that in mind, like our example earlier with H2SO4. So we have 2 hydrogen. So the subscript indicates 2, 1 sulfur, and then 4 oxygen. So you got to remember the little numbers here means there's how many of the letter right in front of it, the element in front of it. So sometimes we have to use parentheses because this is calcium, Ca, one element. So there's just one of them, so we don't have to write a 1. And then if they put a parentheses, a bracket around this NO3, and there's a 2, that means there's 2 units of this whole NO3 here. And you'll learn later NO3 here is an ion. It's called a polyatomic ion. This guy's name is actually nitrate ion, and it's NO3. So there's 1 nitrogen, 3 oxygen, and 1 nitrate, and they said that there's actually 2 nitrates here. So it says, see, there's 2 nitrates. This is the nitrate ion. So another important thing is it shows you how many atoms there are in a compound and the ratios, but it doesn't show you how they're actually bonded or connected. So how many of these elements are in K3PO4? So there's 3 Ks, 3 potassium, 1 phosphorus, and 4 oxygen. So that would give us 3K, 1P, 4 Os. Okay, next one. What about MgOH in parentheses 2? So that means there's 2 of this, okay? 2 of these units. So there's 1 Mg, 2 Os, and 2 H. So it says, how would you read the following formulas aloud? So I would read this as NaCl, 1 Na, 1 Cl. MgO, 1 Mg, 1 O. BaNO3, 2. So there's 1 Ba, that's barium, and this is the nitrate again, but there's 2 of them. So 2 Ns, 2 nitrogen, and actually 6 oxygen because it's 3 and then 2 of it. So 6 oxygen. So Ba1, N2, O, there's 6. In this case, C2H6O means there's 2 carbons, 6 hydrogen, 1 oxygen. So let's talk about composition of compounds. A compound always has the same elements in it. So if we are talking about CO2, every single one of them is CO2. Okay, all of them will be the mass of 1 carbon to the mass of 2 oxygens, no matter what it is, because that's what CO2 is. Every single one of them will be the same. So like for water, it's H2O. It will always have, by mass, if we calculate it, it will always have 11.2% of hydrogen, and then 88.8% of oxygen. So that's for water. But if you talked about hydrogen peroxide, which we mentioned in chapter 1, hydrogen peroxide is not H2O, it's H2O2. So the ratios become a little different. So now there's 5.9% of hydrogen by mass and 94.1% of oxygen, because there's another oxygen right there. So that tells us the mass ratio. This is called the law of definite proportion. So compound always contains 2 or more elements chemically combined, and it's always in a definite proportion by mass. So if we talk about water, the mass percent of H to mass percent of O is going to always be 11.2% to 88.8%. When we talk about H2O2, hydrogen peroxide will always have 5.9% of hydrogen by mass versus 94.1% of oxygen. Now, law of multiple proportion states that you can combine these atoms of two or more elements, and different ratios can give you different stuff. So like for example, earlier we talked about water and hydrogen peroxide. They do combine in different ratios. And then you have here copper chloride, copper 1 chloride, copper 2 chloride. So you see how this one has 1 Cl, this one has 2 Cls, and then this is CH4, this is C8H18. You just combine in different ratios. That's what the law of multiple proportions tell you. You don't have to really memorize anything here, but that's what's cool is you can see what sugar looks like. Glucose C6H12O6 right there. These are the mass percent compositions. You don't have to worry about memorizing these guys. So just to remind you guys, a law is a summary of observed behavior. So observations that we have, we can call it a law. It just tells you the observations. And then theory is something we try to explain. It has to be a hypothesis that's been proven. Remember, laws always are constant because it's just an observation summary and don't have to be modified, but theories sometimes can be proven wrong and modified or discarded over time.